this video, we will be discussing about number of ways to split array. You are given a zero-indexed integer array nums of length n. Nums contains a valid split at index I if the following are true. The sum of the first I plus 1 elements is greater than or equals to the sum of last n minus I minus 1 elements. There is at least one element to the right of I. Return the number of valid splits in nums. So what they are saying is that in the input, we are given an integer array nums. Now in this array, we can do a split at an index I. For example, we can do a split at this point. Basically, for index 0, the split will be at this point. So this will be my left array and this will be my right array, right? If I do a split at I equals to 1, this will be the split. This is the left array and this is the right array. Now, in our right array, there has to be at least one element always, right? So I cannot do a split over here at index 3 because our right array would have 0 elements then, right? So either I can do a split at index 0, that is here, at index 1, that is here, or at index 2, that is here, right? Now, when we do the split, then we need to find out that what is the sum of all the elements of the left array and what is the sum of all the elements of the right array, right? Now, if the sum of the left array is greater than or equals to the sum of the right array, if this condition is satisfied, then we need to count this split, right? So at whichever split this condition is true, we need to count it. Basically, whatever are the number of splits where this condition is being satisfied, that you need to return as your answer, right? So the simple brute force approach is that try each and every split. In each and every split, find out what is the sum of the left array and what is the sum of the right array. And if the condition is satisfied, then count it, right? So for splitting, as I said, index 2, that is the second last index, that will be the last split that we can do, right? So we will run a for loop of I starting from 0 till n minus 1, right? Basically, it will be less than n minus 1, right? So it will go till this particular index, right? So now this I is denoting at which particular index I am doing a split. So when I is equals to 0, then that means I will be splitting here, right? So my left subarray will be from 0 till I and my right subarray will be from I plus 1 till the last index, right? So what I can do is that I can run another for loop of j starting from 0 till I, and I can identify that what is the left sum, and then I can run another for loop of j starting from I plus 1 till n, and I can find out what is the right sum, right? And then once I have got both the sums, I can check the condition, right? If the condition is satisfied, then in that case I will count this split, right? Basically, we can take a variable count and we can count that, okay, this is a valid split, and at the end, we can return this split, right? But here, if you see, this particular loop would be running n times, right? And then inside this, for some of the elements, j is running, and for the remaining elements, this loop is running. So combined, this loop will also run n times, right? So we can say that the time complexity of this code will be order of n square, right? And the maximum size of the nums array that is given to us is 10 to the power 5, right? So this n square approach won't work, right? So we will have to think of optimizing it. So if we see over here, the extra time, basically we had n square, right? So here the extra n is taken because of calculating the sum at each and every split, right? So for avoiding that, we can do some pre-computation so that we do not have to find out the sum at each and every point, right? So for this, what we can do is that we can create a prefix sum array, right? What is a prefix sum array? So in a prefix sum array, each index stores the sum of the elements from the starting of the array up to that particular index. So basically at index 2, if you see, so it will store the sum of elements from the starting till this particular index. So the sum of 10, 4, minus 8, that will be stored at this particular index inside our prefix sum array, right? So if let us suppose that our array is 2, 3 and 5, right? So here it will store the sum of the elements of all these, right? So it will be 2. Then at this particular index, it will store the sum of these many elements, right? Now these many elements sum is already present here. So in this, we will add this. So 2 plus 3 will be 5. Then At this particular place, it will store the sum of all these elements. The sum of these many elements is already present here. So in this, we will just add this. So it will give us 10. So this is what our prefix sum array will look like, right? So let's try to create the prefix sum array of our nums. So the first element will be copied as is. And then in the second element, what we'll do is whatever is the sum till now, we will add this number to that sum, right? So it will become 14. Then 14 minus 8 will be 6. And then 6 plus 7 will be 13. So this is what our prefix sum array will look like. Now, how is it going to help us? So see, when I am doing a split at this particular point, I need what is the sum of this array and what is the sum of this array, right? Now, in my prefix sum, I have all the sums stored, right? So if let us suppose I am splitting here, right? Then for finding out the sum of the left array, I need to find out that what is the sum from the starting till this particular index, right? And in my prefix sum array at this particular index, I have that sum available, right? So I can simply take this value in constant time and this will give me the sum of the elements in the left array, right? Then what about the sum of elements in the right array? So I was doing a split over here. I need to find out the sum of these elements, right? Now, in our prefix sum, at this particular point, I have the sum of entire array, right? And at this particular point, I have the sum of these many elements, right? So, if I subtract this value and this value, I will be able to get the sum of these elements, right? So, simply what I can do is that I can do 13 minus 14. So it will be minus 1. So that will be the sum of these elements, right? Minus 8 plus 7, this will be minus 1, right? So with this prefix sum array, we will be able to identify our sum of left and right subarray in constant time, right? And our time complexity will be reduced to linear, right? But now we have taken an extra space over here for our prefix sum array. So our space complexity will also be order of n, right? So when you will be running a for loop of I from 0 till n minus 1, then the sum of the left array will be whatever is present at the ith index in the prefix sum array, right? This will be the left sum, and the right sum will be, you will take the last value, basically whatever is present at the last, this value, and then you will subtract this value, right? 14. So P of I. So this will give you the right sum. And with these variables, you can check whether the condition is satisfied or not. So let's quickly look at the code. So first of all, let's take the size of nums in n. Then we will take a vector and we'll take long because we will be doing the sum of the elements, right? For our prefix sum array. Its size will be n, and at the 0th index, we will copy whatever is the value present on the 0th index in nums. And then we will start updating it. I will start from 1 because 0th index we have already updated. Inside this, in the prefix sum at index I, we will update it to whatever is present on the previous index plus whatever is present at the ith index in nums, right? Then we'll take a variable count for counting the number of splits. Then we'll run a for loop of I starting from 0, I less than n minus 1, I plus plus, right? Then long left sum will be equals to the ith index in prefix sum, and long right sum will be equals to whatever is present at the last index minus whatever is present at the current index, that is I. Now, if my left is greater than equals to right, then I will do count plus plus, and at the end I can return this count. So let's try to run this. The test cases are accepted. Let's try to submit this. It got accepted. Now here if you see, we have taken an extra space for storing our prefix sum. Now we can optimize it more. We can optimize our space complexity. Let's see how. So if you see over here that when I was doing a split at this particular point, right, then I wanted to know the sum of these elements and these elements, right? So let us suppose the sum of the left array is x and that of right array is y, right? Now, when I try to do a split at this particular point, right, then this element 4 is being removed from the right array and it is being added to the left array, right? So, for the new left and right array, what I can simply do is from y I can deduct 4 and in x I can add 4, right? So, what I am saying is that I will be knowing what is the left sum and what is the right sum initially, right? So, since we start our I from 0 and then we do a split over here. So, initially in our left array there are no elements, right? So its sum will be 0. And in right array we have all the elements, right? So what we can do is that we can identify the sum of this entire array, right? The sum of this entire array will be 13, right? So right will be 13. Now what we can simply do is that when we are splitting at this particular point, right? When you are running your for loop of I from 0 till n minus 1, what you can simply do is that in the left you can add the current element, right? And from the right sum you can subtract the current element, which is nums of I, right? And then you can just simply check that if left is greater than equals to right, then count it, right? So if you see, when my I is 0, I am doing a split here, right? So in left 10 will be added, so left sum will become 10, and from the right 10 will be deducted, so it will become 3, right? Now is left greater than equals to right? 10 greater than equals to 3? Yes, it is. So the count will become 1. Then we'll move to the first index. So we will be here. 4 will be added in left and subtracted from right. Now again, 14 is greater than equals to minus 1. So the count will become 2. Then I will become 2. We will do a split over here. Minus 8 will be added to left, right? So it will become 6. In right, it will be minus 1 minus minus 8. So it will be minus 1 plus 8, that is 7, right? So it will become 7. Now 6 is greater than equals to 7? No. So count will remain as is, and then I will become 3 and we will stop here, right? So this is the count and that is your answer, right? So here, this is the only thing that we are doing. One loop which is running n times and no extra space. Time complexity order of n and space complexity constant, right? But here we will be doing two passes. First to identify the sum of the entire array for this right sum, and then for finding out the count, right? So let's quickly look at the code for this approach as well. So first of all, let's take two variables left and right for storing the left and right sum. Then we will run a for loop in num. So for int num in nums, and then in the right we can add this number, right? So we will get the sum of the all the elements in nums in right variable. Then we'll create a variable count for storing the count. We'll run a for loop of I starting from 0, I less than nums dot size minus 1, I plus plus. Inside this, in the left, we will add nums of I, and from the right we will subtract nums of I, right? Now we will check that if left is greater than equals to right, then count plus plus, and at the end return this count. So let's run this. So the test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.